let's take a look at a few examples involving inverse sine and sine. So the first thing to remember is the domain and range for the inverse sine. So what we needed to do with our sine function is we needed to restrict our domain to make it 1 to 1. So we're going to think about the sine only being between negative pi over 2 and including and positive pi over 2. Alright, so that's our domain, and our range is still negative 1 to 1. Let's not use these set brackets. Let's just do this. Okay. I'm thinking about decimals. Negative 1 to 1. For our outputs, let's just call it y or f of x. So when we're doing our inverse sine function then, inverse sine, we're going to switch those. The inverse of f would be the inverse sine, so the domain of that function is going to go from negative 1 to 1, and the range is going to go from negative pi over 2 to positive pi over 2. Alright, and let's take a quick look at those graphs to remind ourselves. So here we have the sine function in red with the restriction, and the inverse sine, also known as the arc sine. So what we're being asked to do over here is evaluate this composite function. So what we're going to do is we're going to think about what would be the output of the sine of 2 pi over 5, and whatever that value is, we're going to input that into the inverse sine function. So I think something that's really interesting to think about is this property of inverse functions, that if you take a point on the sine function and you switch the x and the y, that point is going to be on the inverse sine. So for example, if we input 2 pi over 5, then the output is the sine of 2 pi over 5 right there. Okay, so this output, sine of 2 pi over 5, is approximately 0.951. Now, we don't have to know that in order to answer this question over here, but let's just go jot this down. Okay, so from the graph, we can tell that this output is about 0.951. So now the idea is we're going to take 0.951 and put it into the inverse sine function. But let's think about what that's going to look like. So if I go over here and I take this output, which is 0.951, which is the sine of 2 pi over 5, the output is going to be 2 pi over 5 because these 2 points just have their x's and y's switched. Alright, so that means that this value here is 2 pi over 5. Now you can see maybe I don't need to go through all this computation. I can just see that these sort of, I hate to use the word cancel, but you know, they eliminate each other in some way. Now we need to be careful because this worked, because this 2 pi over 5, this 2 pi over 5 was inside of the range of my inverse function. Okay, so the answer to this question has to be the answer to this question right here. What angle? We're trying to find an angle. We're trying to find an output. Has to be in this range from negative pi over 2 to pi over 2. So if we go look at the next example, we've got the inverse sine of the sine of 3 pi over 5. So this looks like a very similar problem. Let's paste our domain and range on this slide. But now this 3 pi over 5 is outside of the possible answers to this question. The answer to this question has to be some angle between negative pi over 2 and pi over 2, and 3 pi over 5 is outside of that. Let's take a little look of a picture, because 3 pi over 5 is not one of our common angles, but let's see where it is here. 3 pi over 5. So maybe it might help to think about degrees and turn this into degrees to help you visualize it. Actually, let's think about it with fractions. I know fractions are. So this angle right here at 90 is pi over 2, right? So that's like a half pi. a half pi. All right, so 3/5 is bigger than a half, right? 2/3 pi. Here's 2/3 pi. That's, you know, about 0.666. 0.6666 is 2/3. And 3/5 is 0.6 pi. So it's going to be somewhere between here. 1/2 pi is 0.5 pi. So 0.6 pi is going to be between 0.5 pi and 0.66 pi. If you want to figure out the degrees, I think it's about 108. All right, so it's going to be somewhere about here. So that's about 3 pi over 5. 3 pi over 5. Now, when we're doing inverse sine, remember the output for inverse sine needs to be some angle in here. Some angle between negative pi over 2 and pi over 2. Not y, that's our output for our sine function. Maybe, yeah, we'll just write it like that. Okay. Notation is always a thing. So I'm looking for some angle. Let's write this down. We're looking for some angle, inverse sine of the sine of 3 pi over 5. Okay, so the sine of 3 pi over 5 is the y value at this point. The sine of 3 pi over 5 is the y value right here. So I'm looking for some angle in this pink region that has the same sine as 3 pi over 5. So if you look at this picture, hopefully you can see if you come over here and reflect over the y-axis, whatever this angle is, let's do that in a different color. Let's do it in orange. Whatever this angle is right here, I'm gonna call it R, okay? Whatever that angle is going to have the same y value as 3 pi over 5, okay? Now I want you to notice that this angle R is going to be the same as this angle over here. Now this is not in standard position. I'm just looking at the degrees between the negative x-axis and 3 pi over 5. All right, so what would that angle be? Well, we have pi degrees, or pi radians over here, and then we have 3 pi over 5 there. So we would need to subtract those. So that R value is pi minus 3 pi over 5, which is going to be 2 pi over 5. That is what we call the reference angle. Reference angle. This angle right here, if you take your angle and create your given angle, which is 3 pi over 5, and then see what angle does the terminal side make with the x-axis. Now sometimes that's going to be the negative x-axis, sometimes it's going to be the positive x-axis. That's called your reference angle. And the sine of that reference angle will be the same as the sine of the angle that you're given. All right, so the answer to our question then is 2 pi over 5. All right, so we're being asked the question, what angle has a sine that's the same as the sine of 3 pi over 5, but that angle has to be in this pink area, and that angle is 2 pi over 5. So it gets a little tricky when this number right here is outside of your possible answers for inverse sine. Now, a lot of times students will just put the answer to this as 3 pi over 5. They're just like, oh, inverse sine and sine cancel each other out, so the answer is 3 pi over 5. So I just really want to reinforce why that's not true, all right? A couple reasons is that, number one, the answer to an inverse sine question has to be some angle in this pink area between negative pi over 2 and positive pi over 2. And 3 pi over 5 is not in there, all right? So it cannot be the answer to an inverse sine question. Another thing we could do is think about it graphically let's go back over here to our graph and change the question a little bit. For this question, we had 3 pi over 5 and sine of 3 pi over 5. Well, that point is not on our restricted area for our sine, right? So if I just say, oh, I'm just going to switch these, and my output for my answer, for my inverse is going to be 3 pi over 5. Well, it can't be the answer. It has to be some point on this orange thing. So we say, all right, well, if I put in 2 pi over 5 here for my reference angle, notice this is 0.951. If I put in 2 pi over 5, that has the same output, right? If I put 2 pi over 5 and, well, look, see, it's got 2 pi over 5. It's the same thing. So I can use that for my reference angle, and that will work. All right, why don't you try this one? This is a similar kind of question. Let's remember for cosine, our inverse cosine, the answer, let's just write this. Let's say f of x equals inverse cosine of x. Okay, so the inputs, the domain, I'll write interval notation, has to be between -1 and 1, and the outputs, the range, those are going to be angles, those have to be between 0 and pi. So if we go over here and we look at the unit circle, our answer has to be something between 0 and pi. And the angle that we're given in this question is 9 pi over 8, which is not between 0 and pi. 9/8 is 1 1/8, so that's bigger than 1 pi. So you're going to have to use this idea of a reference angle to figure it out. So pause the video, give this one a try, and then unpause it when you have the answer. All right, so if I look at where 9 pi over 8 is, it's all the way over here. Okay, so I'm trying to answer this question, and the answer to this question is some angle between 0 and pi. So now I need to find an angle somewhere between 0 and pi that has the same cosine or the same x value on the unit circle as the cosine of 9 pi over 8. This is going to be a negative number, right? This is going to be negative, I don't know, close to -1. It's pretty far out there. So if you think about the reference angle, we could draw an angle with the x-axis here. We're going to reflect this over the x-axis now. And we're going to end up with some point up here. And hopefully you can visualize that the x value of this point, is going to be the same as the x value of this point. All right, so what is that angle? What is this angle right here? That's going to be the answer to our question. Whatever that angle is going to be the angle that has the same cosine as cosine of 9 pi over 8, and that angle will be in this pink area. All right, so if we look at this little angle right here, that little one, that's going to be pi over 8. Right? So we've got 9 pi over 8, 9 pi over 8 minus pi to get that little angle is pi over 8. So then I need to subtract pi over 8 on this other side, right? So this is pi over 8, so this is pi over 8. Therefore, this angle is going to be what, 7 pi over 8? 7 pi over 8 if I reflect it over the x-axis. So the x value here is the same as the x value at the cosine of 9 pi over 8, which is the cosine of 7 pi over 8. All right, so these two answers are the same. The cosine of 9 pi over 8 is the same as the cosine of 7 pi over 8. So I could literally replace those as the same value. Now, this angle, 7 pi over 8, is in the range that I need it in this area between 0 and pi. And now I can say my answer is 7 pi over 8.